Hello and welcome to Equations and Inequalities. This is going to be TCMJ's MAT096, and we're going to take a look at section 1.5 and 1.7. So, the thing you really want to be aware of when doing a math problem is what the directions state. I know I'm guilty myself of occasionally doing the problem without thoroughly reading the directions and then making a mistake, but by and large they tend to focus on one of two things. You're either simplifying or you're solving. Simplifying is just cleaning it up. Solving means you're getting something by itself. Sometimes it's as easy as X, sometimes it's as horrible as solve for W in terms of the other letters. So the big idea here is that when they ask you to solve for W, it means we want W alone. In terms of just means the other letters are allowed to stay in the problem. To solve for something, first you isolate it together on one side. I like to refer to this as the middle school dance, because every middle school dance I've ever been to, the boys are on one wall, the girls are on the other wall. So everybody with a W is going to stay on the right. Everybody without a W, namely this 2LH, is going to be pushed over to the other side. Now the W's are all together on the right. This is the hardest move of the whole problem. I'm going to factor a W out. Factoring the W out is going to allow my two W statements to just be a single W statement. It's kind of a sneaky move. And now I'm going to divide by these things that aren't W to find out that my W alone is going to equal A minus 2LH over 2L plus 2H. That's doggone ugly, but that's my answer. They wanted W all by itself, and I've delivered. Here I want to solve for X. Notice that we've got a squared on our X. That's our clue that we're playing with the quadratic rules. If it's a quadratic rule, then we're not trying to get our X's alone per se. Instead, we're trying to get ourselves in a more comfortable position. For me, instead of trying to get my X's alone, I'm going to bring the 24 over into the mix. We saw in the last lesson that one option here is that you could add to the middle and multiply to the end. So factors of 24 that could be interesting. 2 and 12, 3 and 8, 4 and 6. Because it's a negative 24, somebody's got to be negative in the mix here. Negative 3 and positive 8 are looking pretty good. Which means my solutions are 3 or negative 8. So actually two values of X that satisfy this problem. Now this is a little bit uglier. I've got a 6 in front. That 6 in front is going to be a world of trouble if I'm trying to factor that with just two parentheses. I basically am just trying to guess and check to be able to make this problem work. I can't just say X and add to 5 and multiply to 1 because that 6 completely changes the rules. Instead, I'm guessing numbers that go out front. Either 3 and 2, or 6 and 1, or 2 and 3, or 1 and 6. A couple different ways. The good news is it always ends in 1. If this was like 32 in the back, this would just be a real mess as to where things could go. So I'm basically just guessing how this might play out, and then I want to check to see if it worked. If I FOIL this, I get the 6x squared, which I knew. 3x and 2x would make 5x, and that means that's a winner. Completing the square basically has you take everybody with an X, put them together. You factor the 6 out. 5, 6. We already see this is starting to get ugly. And then you pick the number in here that's going to finish off a perfect square. That perfect square is going to be the B value divided by 2 squared. So I take 5 6, I cut that in half to get 5/12. I square that to get 25 over 144, and that's what I want to put here. To balance out life, I take that number times that 6 out front, and I have to subtract it also. Not a very fun process. Really, the only reason I bother mentioning it, other than that it's on WebAssign, is that it helps lead us to the quadratic formula. If you ever wonder where they came up with this whole X equals up to the B plus or minus square root of B squared minus 4AC all over 2A. That's right, I just did that. If you ever wonder where they came up with the quadratic formula, it's based off the idea of completing the square. Basically, some math guy way long time ago did complete the square with just letters, and that gave them the quadratic formula. Populate the quadratic formula in this problem, which PS is exactly how I would prefer to attack it. Just because anytime I get a leading coefficient that's not 1, I go running to the quadratic formula. You get this guy all over that 2 times 6. 4 times 6 is 24. 25 minus 24 gives us a whopping 1. The square root of 1 is just 1. And then I've got my setup. Negative 5 plus 1 is going to be negative 4 over 12. It's negative 1/3. Negative 5 minus 1 is negative 6 over 12. Is negative 1/2. If you set these two parentheses equal to 0, you realize the answers all match. Now, this is a rational expression. We saw that before, and I would approach it the exact same way I saw the rational expressions before. Personally, I would take the common denominator, which is x times x plus 2, and I want to multiply everybody by it. So this is going to be 3 times x plus 2. This is going to be 5 times x. And this is going to be 2 times x plus 2. Opt for a little bit of a darker pen. So this is going to give me 3x plus 6 plus 5x equals 2x squared plus 4x. Now, it's not altogether pretty, but the big upside is that my fractions are gone from the problem. Once the fractions are gone from the problem, it's going to make the problem easier. Fractions make everything harder. You might recognize that this is a quadratic. Because it's a quadratic, I want to collect everybody on the same side. That's 8x. Taken away from my 4x is going to give me negative 4x minus 6. I've got the 3 options I had before. I'm going to pull out a 2 just to make my life a little bit easier. And then I got myself a negative 3 and a positive 1. So my x could either be 3 or negative 1. One extra complication, because this did originate as a rational expression. Remember, I don't want any x value that's going to make the bottom 0. If it makes the bottom 0, it's no good. Alright, so this is basically the same thing. I want to multiply everybody by x minus 1. X plus 1, x minus 1 is going to be a difference of squares. When I subtract x squared from both sides, I get a rather ridiculous statement. Negative 1 equals 0. If this occurs and you end up with something ridiculously wrong, then that means that this has no solution. Or undefined. If you end up with something ridiculously obvious, like 2 equals 2, that's all real numbers. Basically, it means x doesn't matter. It's going to work out by itself regardless of what x is. On this problem, I would suggest multiplying through by AB. Once you do that, it's going to clean up all your fractions, and life's going to get easier. In the interest of time, I'm going to skip this one. Now, this problem looks completely unlike anything else we've seen. We've got fractional exponents. It's just a disaster. The secret here is to try and look past what is wrong with it, and again, look for a pattern. Look for some kind of a clue of something you've done before. As it so happens, if I just let u be x to the 1/6, this whole problem becomes u squared plus u plus 2. Sorry, minus 2. Now this suddenly went from something that's a disaster to something that looks really normal. We've dealt with this a whole bunch. It's going to become a u plus 2, u minus 1. But remember, u is x to the 1/6. Set each of these equal to 0, and then I try and figure out what we're looking at. To fix this, I would raise both sides to the 6th power. 1/6 is like the 6th root, so 6th power fixes that. And 2 to the 6th is going to be 64. 1 to any power is just 1. When I test 64 in the original problem, I realize it does not work, and 1 is my only solution. Alright, so flipping over to 1.7. 1.7 is going to play around with inequalities. You've probably done a whole lot of one-variable inequalities with linears. Quadratics are a little bit funkier. I'd encourage you to think about the graph of this quadratic. If I bring everybody over on the same side, this is pretty straightforward a factor. And I realize that positive 2 and positive 3 are interesting on this graph. My leading coefficient is positive, which means my parabola is opening upwards. So basically, I want to know what portions of this parabola are underneath 0. It's going to be this little window in here. As an interval, that's going to be between 2 and 3. Brackets mean inclusive. You could also just say x is greater than or equal to 2, x is less than or equal to 3. As an inequality, it's just this original statement that I had. This exact same statement could be thought of in these 3 different forms. I'm going to a little bit, I probably have enough time to push forward. Okay, compound inequality. Compound inequality has 2 different rules on 2 different sides. I gotta be totally honest, I absolutely love doing these. It's the only time in math that you get to work on 3 sides at the same time. I want to add 2 to everybody. 3 sides, I'm telling you it's fun. Divide by 3. And now I got my inequality. So x is anything in that window. As an interval, I'd put a bracket on 2 because I want to include it. I'd go up 2 but not including 5. As a graph, because I don't have a squared, this is just a straight number line. And basically I'm going to say, beginning at 2, with a shaded circle, I want to go up 2 but not including 5 with an open circle. So again, I get a quadratic. We saw these before. I don't really have time to be able to do another one. This guy's a little bit different. Again, when you got fractions you don't like, multiply by the common denominator. That's going to leave me with 1 plus x is greater than or equal to 1 minus x. There's a loophole with inequalities. If you multiply or divide by a negative, you're supposed to flip the inequality. I have not done that, so I'm going to keep my inequality as is. I'm going to add an x over, subtract a 1, and divide by 2, and realize that x is greater than or equal to 0. That's my inequality. As an interval, I could just say a bracket at 0 and greater than is going up to infinity. You never put a bracket on infinity. As a graph, this is just a straight up number line. I'm putting a closed circle at 0 because of the or equal to, and I'm going greater.